Hi, this is Joyce Farrell. I want to talk to you about understanding computer files. When you store data in a computer, you have two choices: temporary volatile memory, also called RAM, which stands for random access memory. This is where you store data that the program that you're using currently is working with. You also can store data in permanent non-volatile storage for longer periods of time, maybe days or weeks between using it. Hardware devices that are used for non-volatile storage include hard disks, DVDs, USB drives, and on larger systems, frequently reels of magnetic tape. Every file that you store in a computer system has a name, and the name often ends with a dot and an extension, and the extension tells you the type of file that it is. For example, you might store a document called termpaper.doc, and the .doc would indicate that it's a word processing document that could be used by a word processing program. Another file might be called graduationphoto.jpg, and JPG is an extension that means it's a photograph file. Employees.dat might be a data file. This might be a file that holds the facts and figures about your employees that could be used by a personnel program or a payroll program in your organization. Besides a name, every file has a date and a time that it was last modified, and that information is stored on your system. And besides a name and a time, every file has a size. The size of computer files is measured in bits at the lowest level. Bits are the little zeros and ones that make up the circuitry of the computer system. Bits are so small that when people talk about data, they seldom refer to bits. Instead, they refer to bytes. It takes 8 bits to make a byte, and typically 8 bits are required to store a character, such as an A or a B or a 7. Bytes are so small that when people talk about data, they more frequently talk about kilobytes. A kilobyte is approximately 1,000 bytes, so a small file might be 1 or 2 kilobytes in size. Sometimes kilobytes are too small to refer to large files, so you might talk about megabytes, which are millions of bytes. And computer memory itself is often measured in gigabytes, which are billions of bytes. There are also additional terms that refer to larger quantities of storage. When you store files on a hardware device, such as a hard drive, you might organize the files into folders. And within a folder, you might have additional subfolders. And within a subfolder, you might have even more additional subfolders. The complete list of the hardware device plus all the folders that lead to the ultimate file location is called the file's path. Let's take a look at some typical files stored on a computer. For example, if you're using the Vista operating system and you open up the computer icon, you might see some hardware devices that are part of your computer. This computer happens to have an E drive, a D drive, and a C drive. If you open up the C drive by double-clicking, you might see some folders that are stored on that drive. And I have one called File Demonstration. If I open up File Demonstration, you can see that the path is the C drive, the File Demonstration folder, and then there are some individual files stored there. For example, I have one called Shopping List. It has a date and time that it was last modified, and it's a text document, and that means you can read it, and it's 1 kilobyte in size, approximately 1,000 bytes. If you open up the shopping list, you can see that it's just a short shopping list. As a matter of fact, it has far fewer than 1,000 bytes stored in it. If you right-click on Shopping List and choose its properties, you can see the name of the file and what program opens it, and you can see that it is only 35 bytes in size. That's how many letters it took to store the shopping list. But when you look into my computer, the smallest size that is ever shown is 1 kilobyte. So it's showing you the least number it can show you for this. I also have something called TestDraw. It's a class file. It happens to be a program written in the Java programming language that has been compiled. If you open up this file, It's not very readable. There's a few words in there that you can identify, but there's also a lot of other codes. These codes are in binary and are readable to the computer, but not very readable to you. I happen to have a JPEG file, which is 105 kilobytes, much larger than any of these other files. Pictures take up a lot of storage. If you open that, you see a picture. The employee file is a data file. It's very typical of the kinds of files you'll use as inputs into computer programs. For example, this one happens to have employee ID numbers, employees' last names, first names, and pay rates. And if you wrote a computer program, you might have a statement such as input ID number, last name, first name, pay rate, and it would use this employee data file. Let's take a little closer look at the employee data file and talk for a minute about the data hierarchy. The smallest piece of data that's useful to humans is the character. For example, the M here in Mary Ann. Characters are grouped together to make up fields. A field is a unit of information, such as a first name highlighted here. Other fields in this data file seem to be an employee number and a last name and a rate of pay. Fields are grouped together to make up records. A record consists of all the fields that have to do with one entity, such as a person, place, or thing. And records are grouped together to make up files. A data file consists of all of the records that go together to solve some business problem. Thanks for watching.